Hello and good morning everyone. Today inshallah we will continue revision. I would like to solve with you this exam. It's an application from the first midterm. Inshallah it will be within not this Thursday, it will be on the next Thursday according to our plan, unless there is a changes or something from the university over there. Till the time being, they didn't send me the exam yet, but we are waiting for them. I believe they will have their exam enlistment before us by day or two. I believe it's going to be on Wednesday. Yes, I remember it's going to be on Wednesday in Lisbon. Ours will be on Thursday, which is going to be on the 23rd. We will change the room. It's not going to be this room, but I think for the time being, it could be this room. Okay, I will check and we'll see. Probably I will try to change it to one of the other classrooms in order to be able to spread and let you sit comfortably. At the worst case scenario, we will have it here inshallah. What I want you to do, and I've repeated this in the previous sessions, but it's really very important. Number one, you will have to review the slides carefully. You will have to review the propositions, the statements about the inversion, about the multiplication. I've insisted on this part. The row operations, the elementary matrices, the elementary matrices E1, E2, E3, which represents replacing rows, multiplying the row by a number, multiplying row by a number and adding it to another row, the relation between the determinants values once you play with the rows, how it's going to be, the adjoint matrix. It's really very important to remember how to get the inverse. We know how to get the inverse by two main methods. By Gauss-Jordan method, when you write your matrix and you write one unit matrix from the same dimension and stop the row operations, and also the other method which depends on the determinants, which depends on the algebraic complements or the cofactors of the matrix. This is really very important. This is major. You will have to review it very well. First of all, if I have a matrix 3 by 3, for example, or 2 by 2, I will have to get the cofactors of each element. Do you remember how to get the cofactors? I erase the row and the column, and the rest I will move it, but don't forget to put the sign. This is called a cofactor or algebraic complement. Once you get the algebraic complements for the whole matrix, for all the elements, you will transpose them. Okay? Once you transpose those cofactors, it's going to be the adjoint matrix. So once more, for the steps. We really did go through this plenty of times, but it's a very good reminder as you will see the questions. Number two, or the other thing that I want to stress on about solving the exam, you have to sleep well. Don't come to the exam spending all the night reviewing something. Sleep well. Your brain will work very good when you have enough sleep at night. So sleep well. This is really very important. Finish your studies. You have almost a week. You can play everything. You can do revision as much as you want. But as I told you, just stress on the propositions that I told you about. The multiplication, the inversion, the symmetry, the Hermitian matrices. Do you remember the Hermitian matrices? The Hermitian matrices are the star matrices, which you get the conjugate of the elements and then you do a transpose. All of this will work together in the exam. The exam is not that tough as you imagine, but it needs a concentration, it needs training, and then also creation at the same time. You have to concentrate well, and choosing the right answers in the bubble sheet is really very important. Because of course you know the exam is going to be an MCQ and it has a special way in evaluating the grades, so you have to be focused and step by step. I would prefer myself if you used a pencil, okay, if you used a pencil, lead, and I prefer if you use B or 2B, or 2B for the lead. Okay, it's going to be exactly like you are using a black pen. You read me? And the good eraser with you, it's going to be great. Okay, I will recommend this. Okay, let's go step by step. In the previous revision, I've already reviewed with you stuff about our exam. This question I've showed to you previously, but I will have to go through it once more. He's giving you a matrix, okay? What I really want to focus on today, how to hack the questions, how to go through them, and how the statements that's given is really delicate. So you will have to examine them carefully. He's giving you a matrix, 0, A, 0, E, B, blah, 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 and so on. Under these conditions, indicate which statements are true. And he's asking you, if A, C, E, G, I, J doesn't equal to 0, then A is invertible. How to check this? How to check this? If I wanted to check a matrix to be invertible, the first step to get its rank, okay, yes, you are right. But it is easier on you to get the value of the determinant of this matrix. Because if the determinant is equal to 0, it means the rank is not going to equal to the number of rows or the number of columns. It's not going to be a square matrix. We already did go through this. So the first step is to think how to evaluate this 4 by 4. In order to evaluate 4 by 4, you already know about this. I will try to search for the column or the row with the highest number of zeros. If you look through this matrix, I think it's really obvious that the third column is the one that I will target. Okay, let's do the sign rule. It starts with a positive, then a negative, then a positive. Then go down. Positive, negative, positive. So G should be a positive sign. I'm getting the cofactor or the algebraic complement with respect to G. So I will start with G, eliminating the column and eliminating the row, and the dimension will go less than that. Then I will continue this way. In this how, I will be able to evaluate the value of this determinant. I don't want to waste time in this because you really know how to do it. Okay? So if the final result contains some of these or all of them, you already know that they don't equal to 0, so it's not going to equal to 0. He asked you once more, the determinant of A doesn't depend on J, which means that's a stress also that you should have the value of the determinant. So you get your value of the determinant, keep it, and start answering the questions. Do you read me? He asked you, the determinant of A is equal to this value, you already have it. So you will be able to look at it and choose the right answer. He gave you A is equal to 4, G is equal to 3, and B, C, D, E, F, G, blah, blah, blah is equal to 1. Then the determinant is equal to 12. Once more, you already evaluated the value of the determinant, so it's going to be easy on you to just substitute. Finally, the determinant of A, the length of I, is still insisting on getting the value of this determinant. So this question, okay, it's not hard. This is a very simple question. It will burn time, okay? So you should try to do it as fast as possible. The answers, the first is okay, C is okay, the other choices are not okay, okay? So all of this depends on the evaluation of the value of this determinant. As I told you, I don't want to waste time in this question, as we really do it and you know how to do it. Okay, Ziad? It will give you the same result, but you will do more steps. Okay? So you should focus because time is considered. You should reach the question or the right answer as fast as possible. Okay? Okay. For the second question, that's a very easy one. He's asking you directly to mark the inverse of this matrix. How many methods you can get the inverse of this matrix? 2 methods. The first of them, as I usually recommend once he asks you to look at the inverse of this matrix, is, as you know, writing this matrix like this and putting a unit matrix on the other side. That's a very easy question. 1, -1, and 2, and 1, 0, and 2, -2, 2, and -3. Of course, you will put 1, 0, 0, 0, 1, 0, 0, 0, 1, which is the equivalence line, and you have a matrix, unit matrix from the same dimension. So start your row operations step by step. If you don't remember, I will have to change this matrix using the row operations to be on reduced echelon form. On reduced echelon form. What we mean about reduced echelon form, Farid? is to transfer this matrix to be a unit matrix, which is very, very simple. If you look, I can multiply the first row -1 and add it on the second row. This is first step. Second step, at the same setting, I will multiply in +2 and add on the third row, which is gonna be also handled for you. The second step, I will rock to this element, it will change, and I will try to replace it to be +1 as you know. Then forcing the elements above and beneath to be zeros. Then I will go to the last number, trying to get it to a +1. Do you need me to go with you in these steps, or you already know it? Please, hurry up.
We know it.
Okay, done. Of course, this question also should be done as fast as possible because it is an easy one. Usually, in the exams from our previous experience, there will be one direct question like this one. Get the inverse of a matrix, get whatever, okay? Or multiplying two matrices, but usually you will like to test the inversion as you saw. Okay, starting from this question, you will have to give a little bit thought. As I told you, some of them are direct, like the first one, the second one, but this one will take some time. Also, another remark. In most cases, the exam, in most cases, this is my experience, but it may change, but probably in most cases, the exam, the questions will be shifted and the choices will be shifted. Do you read what I'm saying? So, as I told you previously, if we are 20 students, each one of you will get his own version, replacing the questions and replacing the alternatives. Do you read what I'm saying? And it has a key in it. So, after we scan the papers and go over there, they will be scanned through the computer and the results will be given in seconds. Do you read me? خلاص؟ تمام. حلو. Also, read. Suppose that n belongs to n, which means it's a set of natural numbers. Okay, and e stands for n, and n is greater than 1. So we're talking about 2, 3, 4, and so on. Let A, B belongs to the set of square matrices. So we are talking about matrices starting from 2 by 2, 3 by 3, 4 by 4, and so on. Under these conditions, indicate which statements are true. وهيبدأ يسألك question by question. If determinant A equal to determinant B, in this a must that A is equal to B. If determinant A is equal to determinant B, then A is equal to B. Do you think this is right? How to get this not about speculation, but from the probabilities. Okay, that's already within the matrices and within the evaluation of this value. So this guy is not correct. The other one, determinant of A minus B is equal to 0. So I'm getting A matrix, which is a square one, minus B matrix, which is another square matrix from the same dimension, and then determinant of A must equal to determinant of B. Not correct, of course. You are not. It may happen. It's not necessarily true. It may happen in some cases, but it's not the general case, so it's not correct. Okay? If determinant of A is equal to 1, here's what I'm saying to you. It will depend on the understanding of the adjoint matrix. Once more, Farid, what's the adjoint matrix? What's the adjoint matrix? How do you evaluate the adjoint matrix? Remember, first of all, I will get the cofactors of the matrix. Do you remember what's the cofactors? The cofactors are the determinant, are the value of the determinant assigned to each number of these numbers in the main matrix, but with considering the sign. So you put the sign plus eliminating the row and column and getting the value. That's the cofactor. So if the determinant of A is equal to 1, then the adjoint is invertible and the adjoint A minus 1 will equal to A. Yes, of course. ليه قلت كده؟ لأنه if determinant of A is equal to 1, it means this matrix is invertible. The only way that will prohibit a matrix to be invertible if its determinant is equal to 0. So first of all, determinant of A is equal to a number, okay? Which means A is invertible. A is invertible, it means its adjoint is invertible. So it's exactly okay. And since the value is equal to 1, so the adjoint, how do you get the inverse from the adjoint matrix? I get the adjoint matrix, then I multiply it by 1 over the value of the determinant. Do you remember? So the value of the determinant is equal to 1. So they will be equal to each other. Okay? See how delicate the question. Okay? كل element. يعني if I have this matrix, if this is the matrix, I want to get its cofactors. Okay? So I will go for the first element, eliminate the wrong column. Once you eliminate the wrong column, this is A11. This is the cofactor of A11. Eliminate the wrong column. What's going to be the remaining? 0, 2, 2, and negative 3. Don't forget the sign. The sign is positive. I will get the cofactor of the second element, first or second column, which is it's negative 1. I will eliminate the row and the column. The remaining numbers will be seated. So once you do this, it will be 1, negative 2, 2, and negative 3. The sign, don't you ever forget the sign. This sign is positive, then I will go through a negative sign. So that's a negative sign. A13 similarly like. I will eliminate the third row. So the remaining will be, okay, 1, 0, negative 2, and 2. And the sign is positive, and so on. Those are, and so on for the rest of the elements. So if I have a 3 by 3 matrix, how many cofactors you will have? 9. If I have a 2 by 2 matrix, how many you will have? 4. If I have 4 by 4 matrix, how many cofactors are you going to have? 16 cofactors. Because each element of the elements, you will remove the one column to it, and the remaining you will put it. Okay? Remark, that's the cofactor. So I will do the same for A11, A12, A13. Then I will do A21, A22, A23, similarly like. Just both the signs, negative, it's positive, then negative. Then you will go through A31, similarly like. A32, which is going to have the negative sign. A33, which will be positive. If I want to evaluate A32, for example, I will go to the third row, second column. The numbers will be 1, 1, 2, and 2. So I will put it 1, 1, 2, and 2. Why the idea? What's the value of this determinant? 0. Why? It has 2 rows equal 2 rows or 2 columns equal to 0. Because once more, that if the value of the determinant contain a complete row or a complete column is equal to 0, the value is 0. Or if you have a determinant having 2 rows exactly the same or 2 columns exactly the same, the value of the determinant will be also 0. Are you reading me? This is called, what I have now, it is the algebraic complements or the cofactors. How to change this matrix to be a joint matrix, ya Farid? I will have to get the transpose. So once you evaluate all of these elements, it will be a matrix. Transpose it, that's the inverse. I'm sorry, that's the adjoint matrix. Of course, you know that A minus 1 is equal to 1 over the determinant of A times the adjoint matrix. And once more, the adjoint matrix is the transpose of the cofactors. All of these cofactors. Do you read me? Huh? Tamam? Okay. So this is the. If E is a matrix obtained from IN by switching the positions of row I and 3, so it's an elementary matrix. Am I right? The elementary matrices are unit matrices once you do one of the row operations. But this one in specific, it's about replacing rows. Okay? Continue. With I doesn't equal to j, which means I replace the third, if 3 by 3, I replace the first instead of the second, or the second instead of the third, or whatever. Then adjoint of E is equal to negative E? Yes, of course. Because actually it's not related to the matrices, it's related to the value of the determinants assigned to them. Okay? If E is a matrix obtained from I by switching the position of I and j, which doesn't equal to j, then the determinant of E is equal to 1, or incorrect, and the determinant will be negative 1. Remember, the row operations in determinants. The row operations on determinants, we have 3 row operations in determinants. Two of them will change the value of the determinant, and one of them is not going to change the value of the determinant. If you replace rows, the value of the determinant will be negative. If you multiply a row by a number, the value of the original determinant will be multiplied by this value. But if you add a multiple of a row on another row, the value will be the same. Are you with me? Okay. See how delicate the questions and how they are targeting the propositions that I told you about. So, first of all, as I told you at the beginning, review the propositions carefully. تفضل. علي على صوتك.
هي determinant.
هي اللي هي ايه؟
determinant.
مش سامع.
الجوين هي determinant.
الجوين ماتريكس مش هي determinant. الdeterminant is the value of the original matrix or the value of the matrix. لكن الadjoint matrix is the matrix of cofactors after you add the principal. So they are not the same. Once more is زيادة. بص. That's a matrix. E matrix. صح؟ How to get the cofactors doing this study. How to get the adjoint matrix by transposing those elements. This is what's called an adjoint matrix. This is the adjoint matrix. But the value of the determinant, you evaluate the value of the determinant of the matrix either by Sarah's rule or by Laplace method. Do you read me? Okay, perfect. That's it. Just a second. The first two questions, the third question. The first two questions, they are only exhausting time. For someone who studied well, they are exhausting time. This is why I told you, you have to look carefully for the row or the column with the huge number of zeros. Are you with me? So they will just exhaust time. The third question, this one, is targeting your deep understanding about how to get the inversions and the relations between the cofactor and the adjoint matrix, plus the propositions or the probabilities of the determinants. Let's look to the coming question. Question number 4 will need your attention, more attention a little bit, and still testing the same points. He will start with you, let A be, and he gave you a matrix, which is 0 double n, blah, blah, blah. And it belongs to 3 by 3 matrices, which we already know. And the m belongs to R, which is the set of real numbers, with m doesn't equal to 0, which means these values are not 0, so it's not a null matrix. If he didn't give you this, so this 3 by 3 could be a 0 matrix or contain a complete row with zeros. So you already forbid all of this. Under this condition, indicate which statements are true. As I told you, the head of the question in all of them state the correct statements. He's giving you A. He made a replacement. So once you see those arrows, it means he will ask you about the row operations or the elementary matrices. What's this operation? Switching rows. What is this operation? Adding a multiple of a row. What's this operation? Multiplying a complete row by a constant number. Then determinant of D is equal to negative m3. He is testing what? Please think. He is testing what? It's really very important. The key for most of the questions to understand what he is testing, what he's about. So first of all, he is asking you, that's the main matrix, which is A matrix. So, okay, after doing these steps, if the value of determinant D gonna equal to negative m3, so first of all, I will have to evaluate the value of this determinant. Let's get the determinant of this matrix. How to get the determinant of this matrix, Farid? صح. ها؟ ها؟ Use Sarah's. Use Sarah's rule. Let's use Sarah's rule. Okay, so I have zeros, which is gonna be 0, plus m, which is gonna be m cubed, plus m cubed. That means, for the time being, I have 2 of an m cubed. Continue. On the other side, this is 0. And for that one is 0, and that for this one is 0. So So now I have the value of the determinant. So determinant A, that's determinant A. The value of determinant A is 2 over m cubed. Okay? Now let's review the operations and how they will affect the value of this determinant. First of all, he will change the rows. So changing the rows will affect the value of the determinant. بإيه يا فريد لما switch rows؟ ها؟ Once you switch the rows in a determinant, the value of determinant will be with negative sign. So switching rows, it will add a negative sign. So it's going to be a negative of 2m cubed. This step, it is this guy for me. Then adding a multiple of a row to another row, it's not going to do anything. صح? Then once you multiply by a value, this value will be multiplied in this guy. So it will change to be negative of an m cube. So this statement is correct. The first statement is correct. Are you with me, فريد؟ خلاص؟ اوكي بسرعة. احنا بناخد two directions in some school بتاعت الdeterminants. The first direction will contain 3 parts. Both of them are positives. The second, it will be both of them are with negative signs. So once more, multiplying 0 by 0 by 0 plus, that's the first part, plus take the lower base times the head of the other triangle. لذلك هذا n times n times n. بعدين plus, I will do the same. But for the bottom base of the lower triangle, so it's going to be m times n times n. Those are the 3 parts. You want me to write it for you? Okay, then minus. Each part of the following multiplication will be with a negative sign. It will start with negative. Minus. Multiply the elements of the secondary diagonal. It will be minus 0. Then minus. Put minus first. m times 0. Exactly the same process, but with the secondary direction. It will be 0 also. Then minus m times 0, which is 0. So you will have just only the 2 values that I told you. Okay. A is not invertible. And please be careful about a silly mistake. I myself Farid, sometimes I do it. Okay? Sometimes from the nature that I'm studying just the statement. Okay? So I usually, instead of not choosing, I choose it. Do you understand what I'm saying? So the first statement is correct. Okay, I'm sure about. I will choose it. The second, A is not invertible. Stop. Is A not invertible? Or it is invertible? Think. You already have the value. This is the value of the determinant of A. Am I right? So it's a non-singular matrix. Am I right? He insisted on this once he put m doesn't equal to 0. So he's stating A is not invertible. It is invertible. So I'm not going to choose this one. So please also be careful about the rejection statements. Do you read what I'm saying? Okay. The determinant of A is equal to m cubed. بالتالي ده سهل جدا. شوف؟ يعني بعض choices it's not going to exhaust time. Some of them they will exhaust time. Okay. If m is equal to 2, the determinant of A is equal to 8. You already have it. It should equal to 16. Okay. If the determinant of 1 over m squared, the adjoint matrix is equal to 4, and this is the correct answer. Okay? Simply because you know the value of the A adjoint matrix. If you are in confusion about this, just evaluate the value of the adjoint matrix. Can you evaluate the value of the adjoint matrix for this guy? Can you do it for this guy? The value of the adjoint matrix? I can. How can I do the adjoint matrix very, very quickly? Will make very good sense. Remember, this question didn't exhaust time. This question didn't exhaust time. This question didn't exhaust time. That guy will contain a little bit of time in order to get the adjoint matrix. Once more, can you give me the adjoint matrix for the elements? Give it to me. A11.
Negative.
A11. I will eliminate the row and column. So it's going to be 0 minus n squared. Please concentrate with me. A1, 2. I'm going to A1 and 2. So it's going to be also a 0, negative n squared. So it's going to be a negative of n squared. That's the value, but the sign, it's going to be changed. Okay, the sign of the cofactor. I will go for A13 in a similar manner, going from the first to the third column, and it's going to be a positive value of n squared. Then I will go for A21, blah, blah, blah. I will do the second row also, and I will leave it to you, okay? A21 is going to be the same, eliminating row and column. Eliminating row and column. So it's going to be a 0, and once more it's negative m squared. So it's going to be negative m squared, but the sign is positive, and so on. So now I have the values of these cofactors. I will get the transpose, that's the adjoint matrix. He's asking you the value of this determinant after you do the transpose if I multiply by 1 over m squared. So once you multiply by 1 over m squared, you will find, let me do the first column please. The first column for the adjoint matrix is really simple, it's already here, which is going to be negative of an m squared, then m squared, then m squared. We are multiplying this matrix after finishing in 1 over m squared. معايا فريق؟ لما تضرب ده في 1 over m squared as a matrix, the results will be negative 1, 1, and 1, and so on for the rest of the matrix. Evaluate the determinant. It's going to be very quickly, and you will find the values equal to 4. Okay? لما تخلص هات الديترمنت تاني عشان ما يبقاش في لخبطه خالص. سارس رول بستخدمها عشان اجيب ايه؟ ديترمنت. ماشي؟ مجرد ما تعملها يطلع ب4. طبعا لو خدت بالك يا فريد السؤال ده تافه بس خلي بالك برضه هو ذكي جدا. واقول لك ايه النقط اللي هو بيلعب فيه. ذكي جدا ازاي؟ هو ما اداك الكويستشن ده ادالك بعض الاجزاء اللي فيه اللي انت بتجاوبها ازاي؟ يعني لو انت شاطر هتجاوبها ازاي؟ بسرعه. زي مثلا بص 1 2 3. الثلاثه دول كلهم جم منين؟ من الحركه بتاعت الفك انك هتثبت الديترمنت. لكن ده خد منك شويه ايه؟ وقت. فخلي بالك قوي من التايم مانجمنت في الامتحان ده. طيب انزل. ده سؤال هيحرق وقت. ده سؤال فيه تفكير يحرق وقت. ممكن يبقى سهل جدا. It could be very simple question and it could be a very time exhausting question. In anyhow it's going to be simple, but it will exhaust time. So just be careful and start with it step by step. Okay? What is this matrix called? فريد matrix اسمها ايه؟ augmented matrix. معلش يا فريد وانا بذاكر او انا بحل الامتحان انا بعمل زي الكمبيوتر بيشفت. يا ترى ده في انه جزء؟ البتاع دي في انهي حته؟ system of equations. Am I right? وسيستم of equations يعني غالبا طالما variables هيسالك في الكلاسيفيكيشن بتاع system of equations. انت فاكر السيستم of equations how to be classified? consistent, inconsistent. consistent determinant, consistent indeterminate. اللعبه دي بيدخل معاها مين؟ جنى. اللعبه دي بيدخل معاها مين؟ رانك. بيدخل معاها الرانك. تعالوا نشوف بقى. بيقول for each delta which belongs to R and for each gamma which also belongs to R, consider the system of linear equations over R whose expanded matrix, which means the augmented matrix, is that matrix. مجرد ما بصيت how many variables? This system, how many variables? 3 variables. This is variable number 1, x, y, and z. So I have 3 variables. Are you with me? Okay. Under these conditions, choose which statements are true. اختار الstatements true. نفس الكلاس بتاع الصور. بيقول if delta is equal to 0 and the gamma is equal to 1, the set of the solutions of the system is بدأنا بغتاتة. يعني إذا ده معناه غتاتة. غتاتة أنا ده. يعني ده معناه إن حضرتك لازم هتبدا تعوض، وخلي بالك كويس جدا لان انا برضو بلبس نظاره واخد بالك، فممكن وانا بعوض بهدلهم في بعض. فهبدا هو واحده واحده، يعني ده لازم حد بيكتب كويس جدا وبالترتيب. خلي بالك من الارقام 0 نيجاتيف 1 بعدين هو حاطط جاما كام ولا قيمه جاما كام؟ 1 بعدين ده 2 السكند رو هيبدا 1 بعدين هيدينا الدلتا ايكوال تو 0 بعدين 1 بعدين 0. For the third row please it's gonna be 1 also a 0 then gamma is equal to 1 then gamma square minus 1 which is gonna be a 0. For the last row it's gonna be a 2 then 2 times 0 am I right? Well 3 minus 1 which is 2 plus that's a 0 that's a minus 1 plus 1 which is gonna come to a 0. Am I right? Okay. Now you have a system which is called over-determined system. Over-determined system. ليه بيطلق عليه over-determined? How many variables يا فريد؟ But how many equations? 4. Okay? طيب هو بيسأل if this system set of solution is gonna be negative c 2 plus c and c. How to be sure of this? I will try to work with it. Okay. How to get the result? Try to reduce reaction 4. You will have to solve it. Try to get reduced reaction 4. So I will do, let's try it together. Most of the rest of the questions will be the same, so I will start with this one. I will move the second row to be the first row. Please focus with me. So this is 1, 0, 1 and 0. And then I will move the second row. Once I'm moving the second row, multiply negative. So it's gonna be a 0, 1, negative 1 and negative 2. I made a replacement and multiply by negative in order to get this movement also at the same time positive. The third row is going to be 1, 0, 1 and 0. I want to change it in Jana. I will multiply negative and add. Negative 1 plus 1, negative times 0 and 0, negative 1 plus 1 which is negative 0 plus 0, so it's 0. That's that third row. So I'm now a little bit relieved. For the last row, I will multiply negative 2 and the add. Once you multiply a negative 2 and the add on the last row, it's going to be also zeros. Let's talk ranks. Let's talk ranks. ايه اللي حصل دلوقتي؟ ايه اللي حصل؟ اللي حصل ان انا كان عندي كنت بادئ الشغل بتاعي ده how many unknowns؟